Welcome back, statisticians. We've been separated for a while. So these are, some of these are for fifth period. You already have these filled in. So you might want to just fast forward a little bit until it gets to the point where we were. Sixth period we didn't start, so you'll need to start from the beginning. I also neglected to remember that I still had a couple more pages that I needed to Xerox for you. But that's okay because you can finish taking the rest of the notes tomorrow in class. I will have the Xerox copies for you with the substitute because I will be out working on geometry stuff. All right, so sampling distributions for sample means. We're going to look at the similarities and the differences. Again, we're drawing samples all of the same size from the population. That's the same as the proportions. And if we compute the statistic, the mean for that sample, of course, it would be an X bar because now we're looking at averages. And the probability distribution is still called a sampling distribution, just like it was for the proportions. This time, it's the sampling distribution of sample means, and therefore we call it, our cute little name is X barbell. And of course the schematic is that I start with the population. Its center is at mu and sigma. We could also say mu of x or sigma of x to denote that it does in fact come from the population, although typically we've just gone with these notations as we've worked these problems since chapter 2. And from that population, we are going to draw samples. Actually, we're going to draw simple random samples, all of size n. And so imagine that we went out into the quad and we each took a sample of 10 and we found their IQ, and then we came back and we each have our sample of 10. So of course we would want to take an average, so each of us would generate our own X bar. And then we would create a distribution for those sample means, since that's what they're all called. Distribution, struggling on the spelling. And we would start with a histogram, and it would look like the blue graph on the Rice University lab. And so it would have a center called mu of x bar, which we know is equal to the population mean, and it would have standard deviation for x bar, which we know the formula for that as well. But now we have one little special caveat that the population has to be greater than or equal to 10 times the sample size. So we have to add this piece every single time we start talking about standard deviations for samples. Excuse me. So of course the mean is for the parameter, the mean is mu, and again the standard deviation is sigma. And sorry that the format looks a little different on here. For some reason TouchCast kind of tweaks it on us. Versus the mean of the sampling distribution, we call that mu of x bar, but that we know is equal to mu because x bar is going to be an unbiased estimator. And the standard deviation for x bar is the population standard deviation over the square root of n. And again, that's only if, big if, the population is greater than or equal to 10n.